Hello everybody, we will discuss classification tree as a part of accident data analysis. You have seen in last class we have discussed regression, we have discussed only the concepts and the basics and some results. For classification tree also I will do the same thing, we will not be dealing the detailed mathematical issues here, because our purpose is not to treat the mathematics, our purpose is to see how classification tree will be useful in accident data analysis. So, the concept will be discussed, that CART concept, here CART stands for classification and regression tree, classification and regression tree. And then some on example we will see, and then performance matrix of classification tree will be discussed. In fact, this performance matrix will or classification regression tree, or in case of prediction also it is used. Okay. So, general one. So, what is classification? Classification is a systematic approach by separating various entities into several classes. Separating various entities into several classes. For example, if I say that living animals, so if you say that the living bodies, then you can find out animal and non-animal like human. Again, animal you can find out different kind of, some animals are wild animals, some animals are domestic animals. So, suppose given a animal to you, you are asked the animal from which class. If it is cow, you will say it is domestic animal, but if it is tiger, you will say it is a wild animal. So, that is basically the concept of classification. So, another concept classification problem will be, suppose you are the bank manager and then you know you are disbursing loan to people. So, there can be a group of people who are always defaulter, they will not repay the loan. So, giving the person individual value, individual attributes, the person's income and socio-economic status, and you can find a build a classification model, and which will ultimately tells you later, given this information, whether the particular person will be repaying the loan, or if repay, what is the probability of repaying, something like this. So, and same thing can be thought of in accident scenarios also, because you have seen that accidents are result of deterioration or deviation from normal condition in from the process point of view, procedure point of view, from the technology point of view, from the environment point of view, from organization point of view, many things. So, in the lower level that they are basically unsafe acts, unsafe condition, incompetencies, inspection, lack of inspection, lack of removal, many other things are there. So, now it may so happen that the situation can be of different severity level. I mean, a situation can be of fatality prone situation, another can be that high severity prone situation, another situation can be of less severe or maybe severity point of view. So, the if the workplace conditions are given to you, and then you are asked that you tell that and if today someone wants to work there, so what is the exposure to, what severity level of exposure he or she will be having, then also you can go for classification model, because here the class is the severity and there will be different severity class. Okay. There could be many other examples in the safety domain that can be talked about. So, you just think and you find out the way, but here we are basically interested to tell you that classification is a good tool when you have large number enough data, and then you have and the attributes or the variables of interest are also logically and correctly quantified and and data are collected accordingly, then you can use classification model to predict accident situation or accident severity or incident categories or something like this. Now, classification is having of two different types, one is supervised, another one is unsupervised. When you know the class, for example, for bank it is defaulter or not defaulter, for accident the situation is grave or situation is normal, for people maybe he will given this job he will be committing some mistakes or not. So, in that case when the classes are known it will be supervised, but in some cases classes are not known, mean what actually will happen, but there are so much of features or the characteristics which are interest. For example, we have different sections with the all the work system component values, characteristics values. Suppose we want that you that cluster the groups or the workplaces into different zone of safety level point of view, and then ultimately you have to go for unsupervised method like clustering, and then after that seeing the features you will name the clusters. Okay. So, one of the supervised classification method is classification in regression tree. This is a data mining techniques and it is basically used in also coming under the machine learning concept. So, what is the concept here? Basically this model first learn using the training data, and then we apply the model using test data. So, even that is true for the regression also. Suppose you have n number of capital N number of data points, you take small n data for training, then n minus n whatever another small amount is there, like 70% of this is equal to 70% of n, then this may be 30% of n. So, you use this to learn the model, and this small data for apply the model to test whether model is working or not. Here what happened, basically you will create a learning algorithm, and that algorithm will learn by considering the instances one after another, and then one model is adequate enough. So, in order to test whether model is learned adequately, you apply the model with another set of data, and you see that whether actually model learn adequately or not, or you require to refine the model. Okay. So, this is true for all prediction model including CART, regressions and other things. So, now let us see the basics of CART. Actually, it is a decision tree based classification model. It basically split the entire data into different parts. The splitting is binary in nature, means two, like I have the entire data set like this. First I split like this is one, this another, then again I split this making it 2, another one this making it 2, like this binary splitting continues. So, the tree build by splitting one node into 2 child nodes. So, as a result we will start, when we start with all data are in the root node, then you considering certain attributes, the split will take place and it will go to child node 1 and then internal child node 1. So, this is basically node 1 and node 2, these two are children to this root node. Now, when we are saying child node 1 here, means this is not further splitted, this is the end here. Now, the internal node it can become parent to another child nodes. Okay. So, ultimately at the bottom all child nodes will be there. What will be the child node? Child node is one where the data is homogeneous in nature, or further splitting will not increase the homogeneity of the data. Okay. So, that is what is the way classification works. So, root node no incoming edges, 0 or more outgoing edges, internal node exactly one incoming edge, 2 or more outgoing edge, and leaf or terminal node, these are child node, exactly one incoming edge, but no outgoing edge. Okay. So, how this CART model will use? They basically consider different sets of attributes, these are x, or other way in the regression independent variables we say same manner. Then the model learns and output will be the classification class label, which class of instant it is. If it is individual related, what type of individual he or she is. If it is workplace related, what type of workplace it is. It is severely accident prone, or it is a safe, or it is basically moderately dangerous, something like this. Okay. So, what I said that you have data, huge data for different attributes. So, this data will be splitted. The split take place in binary mode. First root data set will be split into two children nodes, and then again they will be split, and ultimately at the bottom there will be only the leaf node or terminal node. So, what is the basic of when do you stop? We stop when the homogeneity of the data is not further improved in the child nodes. Okay. So, let us see one example. Suppose a company is experiencing serious accident over the last 5 years. They have been collecting records of each of the accident occurred in the plant. The data consisting 500 records are retrieved from the company for analysis with an aim to predict the incident outcomes, like whether injury, near miss or property damage, what kind of accident will take place. Okay. The attributes used in the data set provided below use CART algorithm for prediction. So, what are the attributes? Month, which day, which location, incident event, what type of event, what is working condition, machine condition, observation types, incident types, employee time, generation, so many. So, mainly these are all location stamps, time stamp, process related information, procedure related information, then your employee related information, and finally, obviously what you want to predict. So, that categorical variables, most of them are categorical in nature, some are numerical. Okay. So, there are different category, this is what is the data set. Now, we want to use this data set and we want to show that how CART will help us. Please keep in mind that this data set is not real data, this is a hypothetical data. Again, although there is touch of reality from the attributes point of view, but data are not real. So, okay, their data we have created. So, we have used some software. Okay. So, you use software, I have already given in last class different software. So, use any of the software, and then what happened, you will basically find out interestingly that how many class are there. One is injury class, near miss class, property damage, 3 class, that is what we want to predict. Given the workplace attributes, individual people working attributes, all those things. So, you want to know that whether given that situation, which one is most likely to occur, injury, near miss or property damage, something like this. So, here at the root node you see that only these 3 classes are there, injury, near miss and property, with this number of observation. There are total number of observation is 342. Okay. Then it is questions comes that what are the which attribute you will choose. Basically, you try to use one of the attribute at a time and then do the split here. The split takes place depending based on certain mathematics. So, that is known as basically growing. So, what we will do at this point, you have to find out to consider each of the variables, okay, and then or attributes, and then find out that which attributes is giving you the maximum improvement in terms of homogeneity. So, here the class homogeneity vis-a-vis the class homogeneity here at the child node they will be different, and here the homogeneity will be less compared to this. So, that is the issue, or other way we can say impurity. So, we will choose that variable which in the split which gives you the maximum improvement from homogeneity point of view, maximum gain from homogeneity point of view. That means, the impurity will be reduced maximally. So, as there are many variables to attributes together, you will take that one which gives you the maximum at the beginning, that is the starting point. So, we are saying basically that improvement 0.0 this. So, please understand that there are different index like Gini index, GINI Gini index, then entropy index, then misclassification rate is there, misclassification probability. So, there are many such measures index are there which used to find out the impurity. The impurity here and impurity here, when they are compared, here impurity will be less. So, that is the improvement, or impurity in other sense we can say homogeneity and homogeneity here, or heterogeneity. So, okay. So, using those three, one of the three indices like again Gini index, entropy and another criteria, you find out which variable is giving you the maximum benefit. Okay. So, that means the entire data set you see 342 was the initial, now it is split to two parts. In this case, wherever it is 195. So, 342 minus 195 will be coming here. The what is the benefit you found out here? Here injury 44, 26, 28, here 40, 24, 35, but here in this class 51% injury side. So, it is basically improved one. It is again it is not a very good splitting in the sense that the homogeneity is not that much improved, but it is improved one. Then now you are dealing with this set. So, originally 342. So, then 195 here, then 147 here. Now, this one, this is here. So, this one again, this data you are finding out with all the variable, which one is giving you the maximum benefit. Here we found out the gender is giving maximum benefit. So, gender male and female. So, then again the split has taken place. Similarly, this one also like this. So, here what happened, this become 43%. Here this is the maximum, here it is 62%, here it is again 41%. So, in this manner you continue, and finally, you will finish or you will stop when there is no further improvement possible given the attributes and using any of the impurity calculation methods. So, here what happened, 51% maximum, it is 40, 28, 48. Okay. So, the data is not that good here, because, or other way I can say the variables, for the purpose it is used, they are not able to explain that much, but nevertheless it has given you some information that which are the variables contributing. You started with month, then gender, here day, again month comes. So, then again what happened, gender comes. So, month and gender and day, these are coming in this data, because hypothetical data we have considered. We might have committed mistake in putting the values. In reality, it may not be this much, it may be much better, even or much worse also, absolutely. But this is what is the method of CART. Then what happened, given attributes, you will be able to predict which class it is there. So, there is the last step is the prediction. Okay. So, so that means you please understand that this is basically tree is generated. So, what ultimately we have done, I just forgot to tell you. So, this side we are talking about the training side, and this is the test. I am sorry that I have started from here and finally landed here, but it is not that. Using the 70% of the training data, you got this is the end, and here test data, and almost they are training and test giving you the similar kind of results, and that is to be. Okay. So, let me repeat, growing, stopping, prediction, this is important. So, there are many criteria index that to be used. Now, you start with the root node, you ultimately go for the children that leaf node, final one. The leaf node is one where you cannot further split, because that split will not give you any improvement. So, there will be two sets of data, training sample and test sample. and in the training sample like this and the test sample like this, this is given here. It is not that from here that again day, actually here month, gender, day, this is coming. It can be further split, but we have not shown because the further split is not giving you better result. Okay. So, correct it. Now, what will happen? So, using the model, the cart, so you will be able to given the attributes, you will be able to predict under which class. So, here the actual class vis-a-vis predicted class, these are the predicted class, these are the actual class. When you observe the data, you can find out a classification table like this, where actual class and predicted class will be represented in this manner. Then this one EAA or EBB or ECC, these are the frequencies which talks about that actual class and predicted class matches, and rest, that is a diagonal element, and rest of diagonal elements frequencies are mismatch or misclassification. This matrix is known as confusion matrix or misclassification matrix. So, in the confusion matrix or misclassification matrix, the diagonal elements are the correct classification, off diagonal element are incorrect classification. So, the classifier accuracy or classifier performance will be tested using this confusion matrix. There are several parameters or several criteria have been developed. One of them is, or performance metrics have been developed, one of them is accuracy, another one precision, and some more are there. So, what is accuracy? It is defined as the ratio of the correctly predicted observations, ratio of correctly predicted observation to the total observations. I told you the diagonal frequencies are correctly predicted. So, I equal to 1 to A to C E I I, so A, B, B, C, C, divided by total observation all. So, that means actual one from A to C and predicted one from A to C, that I A to C, J A to C, and every observations you have considered, that is the accuracy. Then another one is the precision. It is defined as the ratio of correctly predicted observations, under a particular class to the total predicted observation under that class. So, you actual class you consider class A. So, what is the ratio of correctly predicted observation of that class? That is nothing but EA. Then what is the basically total predicted observation under this class? So, under this class total predicted observation is EAA, EBA, ECA. EAA, EBA, ECA I equal to A to C. So, that is your precision. So, what do you want? You want accuracy should be high, precision should be high, that is the issue. So, now the third one is recall. What is recall? Recall is EAA by this. So, you see it is the ratio of correctly predicted observations under a particular class to actual observation in this class. You have this is the predicted part and this is the actual part. The correct one is in our case, correct one is this one is correct, this is correct, this is correct. So, this is actual B and C, predicted A, B and C. What is recall? Ratio of correctly predicted observations. So, this one divided by the total number of observations, that is basically that is actual observations in this class. So, this one, this plus this total, and if you take divide by this total, then this will be precision. If you divide the correctly classified observation by the column row total, it is giving you recall. If you write like this is the predicted and this is actual. If you do the same thing, that mean divide the correctly classified one by the column total, in this fashion, then it is will be the recall. Okay. So, now what happened, this precision and recall are very important one. So, these two are combined in a matrix which is known as F measure. F measure. What is F measure? It is a metric calculated from the weighted average of precision and recall. It can be expressed in the following equation, where beta denotes the relative importance of recall versus precision. So, what is F measure? F measure is 1 plus beta square precision times recall by beta square into recall plus precision. When beta equal to 1, it is F1 score. Okay, so, that is basically weighted combination. Now, what will be the beta value? So, beta can be 1, beta can be other values also. So, what we say that F1 score is used, or other major F values you can take, but F1 score is mostly used. So, this basically gives you a metric which is basically combining the two important performance metrics called precision and recall. Okay. Then another one that is also very important one, which is known as receiver operating characteristic curve. So, this is basically the sensitivity and specificity is there. The ROC chart shows that false positive on x axis and probability of target when it is true values, something like this. So, the area under this curve is very important, and that will basically talk about the performance of the case. So, true positive, true negative and other things. So, I will not discuss here. So, what I request all of you, just please go through this ROC curve little more detailed, and then the true positive, true negative, then sensitivity and all those, the specificity, all those measures also please go through and do your home assignment. Otherwise, if you are not able to understand, put in the discussion forum, because these things are important for not only for understanding ROC curve, or also for the examination purpose. So, the area under the curve is very important. That area under the curve will basically talk about what is the performance of your that classifier. So, area under the curve, the more, that is the better one. In practice, for most practical purposes, this will be 0.5 to 1. Okay. Now, for that particular data, what we have developed the classification tree. So, we are basically seeing that what is the measure. So, in the training data and test data, two kind of data set we have used. In the training data, that injury, near miss, property damage and overall. So, the predicted value and this is the actual value. So, 135, 22 and here it is 0. So, that means you see that so much of misclassification is taken place. So, the accuracy is basically total accuracy which side. Okay, the same thing from the test data also you can do, and this one given from the test data point of view. So, currently classified 57 and plus 7 plus 0, 57 this plus 0 by total observation 57 plus 13 plus 0, 38 plus 7 plus 0 and your other one is 31 plus 12 plus 0. Okay. So, so actual, if I see the actual property damage case, this, if I see the predicted property damage case, in both cases it is 0. So, it is very bad model, I can tell you, and accordingly what happened, accuracy is 0.405, precision is 0.4524, recall is 0.81. Okay, recall is better and F1 score is like this, but particularly I am surprised to see this, that this side it is completely 0. Okay, but if I see that these are the predicted, then the actual one, it is a huge number is there, 79 plus 28 plus 18 and here 70 plus 22, the 23%. अच्छा, property damage case, okay, this is basically percent correct or predicted one is 0. Okay. So, okay, this is not a big issue for all of us. What is the important thing is that, so CART can be used for prediction purposes, and once you use any software, you will be getting such confusion or classification table. You will be getting it for the both the training and test data. Then you can find out all the performance measures with the reference to reference to the CART model, and then accuracy, precision, recall, all should be high value. This should be good value. So, and then then ultimately there is no such 100% or absolute threshold value for all those things, but it should be as good as possible. So, if you go by the external literature, so you may find out some of the useful values for accuracy, precision, recall and F score. So, these are the issues what is to be dealt with before using this model for prediction. Okay. So, I hope that this lecture makes some sense to you also. This is a classification model. CART, basically we have shown you the classification tree, not the regression tree, but the classification and regression tree, it is commonly used name. So, it is also similar to your regression, but in classification tree you will see the attributes are categorical in nature, and in regression tree attributes will be continuous in nature. Okay. Thank you very much. From the accident investigation and accident analysis, data analysis point of view, this is what we have covered. This is a huge topic. In fact, there is one concept called safety analytics. This in today's very hot topic is safety analytics. Safety analytics. Okay. Analytics. In fact, under industry 4.0, so you will see that now this analytics, AI, machine learning, then the sensor data, all those things means safety, maintenance, operation related all data together you will use, and ultimately you find out that it will give you a better prediction model. So, safety analytics is is an area to work on, particularly if you are interested in safety analytics. So, there is a journal called Safety Science. There is a special issue, Safety Science, special issue on safety analytics, where you can, if you are researcher, if you are practitioner who want to disseminate your knowledge, you can send this paper. This is basically we are organizing this special issue. Okay, thank you very much. Have a good day.